All right, everybody, welcome to this video on phase changes. Today we're going to be talking about the changing states of matter for water. So I've introduced you to this graph. It's going to be a graph that you need to make friends with because you're going to see it over and over again. It's called a phase change diagram. And it helps us describe what happens when water turns to ice, or when ice turns to water, or when water turns to steam, or basically anything regarding phase changes in matter. So phase change diagram. All right, so with this diagram, let's just introduce you to what you're seeing. On the y-axis, we have temperature, and as you can see, it's increasing as you go up. Down here on the x-axis, you have time and heat energy, increasing as you go over that way. And you have a line here that's kind of looking like up and then flat, up, flat, up, flat. Many of you, when you predicted your graph, you predicted something that looked like this. As time and heat energy increase, temperature will increase. And that makes some sense, right? Why wouldn't temperature just keep increasing as you add heat? But we don't actually see that, do we? What we see instead is a line that increases as you add energy and then flattens out, so the temperature remains constant, and then the temperature increases, remains constant, and then increases. Something important we need to add right now as well is that right here where that line goes flat, for water anyway, it's 0 degrees Celsius. Should add Celsius over here. And then where that line flattens out here again, that's 100 degrees Celsius. So those are two important temperatures for water, and we'll find out in a moment why. So that's what happens when you add energy, heat energy, to temperature. Now, of course, the opposite happens when you take away heat energy. The temperature goes down, remains constant for a bit, goes down, remains constant, goes down. So this is a phase change diagram. What's happening here? That's what we're going to explain right now. So if you zoom in, so what's really cool about the changes in phases of matter is, from a chemist's perspective, is zooming in, you can see the particles. And what happens on that level with those particles as you add heat energy? Well, down here below 0 for water, I'm going to draw a picture, and you can guess what I'm drawing maybe. It's a particle model of matter, and this is a solid. So I'm going to change the color on this, make it green. So there's a solid down there. Now, as you add heat energy, that solid turns into a liquid. I think we all know that. But before it does, something happens. The temperature stops changing, and right here, this is called melting. As we add heat energy, solids melt, and then they become a liquid. And I think we know this. All right, and so once they are a liquid, the temperature can start to increase again. It increases, it increases, it increases, and then here it flattens out, and we get something called boiling or evaporating. All right, so boiling or evaporating, and then once all that liquid has boiled, it is all in a different state of matter. It is all a gas. All right. And so then if you take away energy, the temperature will go down, and then it will stop going down. And at this point, we have what's called condensation. So the gas is becoming a liquid. Once all the gas becomes a liquid, the temperature starts to go down again until we hit another point where that liquid becomes a solid. We call that freezing. All right, so this is a phase change diagram. It just shows you that temperature will increase until it hits a phase change. And then at a phase change, the temperature stops increasing and that substance either melts or boils or condenses or freezes. At this point right here, at 0 degrees Celsius for water, we have a physical property called freezing point. And so this is unique. This temperature right here, 0 degrees Celsius, is unique to water. Other substances have different freezing points. And then up here at 100 degrees, I should change the color for this as well. Up here we have, you guessed it, boiling point. The boiling point. So the boiling point for water is 100 degrees Celsius. All right, so what's actually happening? So we have the question that we asked, does temp of water change during boiling? That was our original question. Well, we can make a claim now that we have some evidence. And if you look here where the boiling happens, does that temperature change? No. Temp does not change. And we got our evidence from that video that we watched, from that simulation, from our graph. So the reasoning for this is a little complicated, so I won't get into it too much, but just know that energy can only focus its efforts on one thing at a time. And so when we add heat energy to this water, it's saying, well, I'm going to increase the motion of the particles from a solid to a liquid, for example. And so motion of particles, that's what temperature is. And so the temperature will increase as the motion of the particles increase. But at this point where it starts melting, we have that phase change. That energy can only do one thing at a time. So instead of changing the temperature or changing the motion of the particles, it actually goes and focuses its effort on changing the relationship or the interactions between the particles. And that's what melting and boiling are. And so we could say that the heat here, heat energy, is changing the interactions between particles and not increasing the motion of the particles. In other words, the temperature. All right, so there we go. That is a phase change diagram. The important things for you sixth graders to remember: as water goes from a solid to a liquid to a gas, or the opposite, that is a physical change. And these points right here, freezing point and boiling point, These are physical properties.